So this first video is going to talk about conditional statements, and we're going to use what's called an if-then statement to be able to make conclusions about different topics in geometry. So a conditional statement is if you are a red raider, then you are respectful, responsible, and involved. A conditional statement always has a hypothesis and a conclusion. So if you are a red raider, that's going to be the hypothesis. And then you are respectful, responsible, and involved. That is the conclusion. So hypothesis comes first. What are you stating? Then what can you conclude from that? Another way you'll hear that is if P, then Q, where P is your hypothesis and Q is your conclusion. Okay, so if hypothesis, then conclusion. And we use P as also the given and Q as the prove. What were you told? What are you trying to prove? And then that can either be true or false. Sometimes it may be false. We have to then make a counterexample. So not every conditional statement is going to be true. We have to take the ones that are false and be able to prove it by drawing a counterexample. So a midpoint divides a segment into two congruent parts. First, let's identify the hypothesis. The hypothesis is a point is a midpoint. The conclusion splits a segment into two congruent parts. So for my conditional statement, my if-then, I'm going to take this down here for a second, and I'm going to add two things. If a point is a midpoint, comma, then, just so it sounds grammatically correct, then it splits a segment into two congruent parts. So you're taking your hypothesis and your conclusion for a conditional statement. You're literally just putting an if and a then in front. So is this conditional statement true? If a point is a midpoint, does it actually split a segment into two congruent parts? So if I have a segment here, AB, and I draw a midpoint, does it actually split the segment into two congruent parts? And it does. So it's actually true. So we don't need to provide a counterexample. Is it true? Yes. Next one, all right angles are congruent. So the hypothesis, two angles are right angles. The conclusion, they are congruent. And as we go throughout the year, we're actually going to abbreviate this as much as possible and not actually really write out any words except for if and then. So my conditional statement is, let's move this down here again. Oh good, I can split this. So if two angles are right angles, then they are congruent. So is that true? Think about two right angles. If I draw two right angles, there's one right angle, here's another right angle. They're both 90 degrees. So is the conditional true? Yes. All congruent angles are right. So that's the inverse of what we just did. Our conditional statement is if two congruent angles, then those two angles have to be right angles. So then they are right angles. So it's an if-then statement. It's a correct conditional, but is the conditional actually true? So if I draw two congruent angles, like this one that's 40 degrees, and this one here that's 40 degrees, are they actually right angles? So is the conditional true? The answer is no, because I was able to prove the hypothesis correct without the conclusion being true. And my counterexample is that picture. Any picture you can draw that makes this statement, the hypothesis, true, that disagrees with the conclusion is a good counterexample. And our last one, if angle A is acute, then the measure of angle A is 15 degrees. So the hypothesis is angle A is acute angle, then it has to be 15 degrees. Is that true? Well, if I draw this angle and I call it a 15-degree angle, yes, that angle A is an acute angle that's 15 degrees. But remember, acute doesn't have to be 15. An acute angle could be 35 degrees, or 50, or 75, or 88.7. Anything below 90 degrees. So is it true? No. And here's a counterexample drawing a 35-degree angle.